Good morning, friends and MCC family. Today we'll be discussing the importance of cleaning and maintaining the machine spindles, chuck components, and checking the conditions of your chuck fingers. Are you having any issues holding on to material or parts after pickoff? Is your bar stock moving during machining operations? Adjustment nut maxed out forward during the machining process? Can you slide the finger holder forward and back? When was the last time you inspected your spindles, sleeves, and fingers? And finally, when should you replace your chuck fingers? If you're having any of the issues mentioned, then it's time to inspect and clean all the components that are related to the chucking mechanism. Cleaning and checking once a year is ideal, but if you're running hot and heavy, maybe even sooner. The machine used for this demonstration was a Citizen-Cincom M532. The first video will be discussing all the areas that need to be inspected and cleaned. The second video will discuss the markings on the finger holder and how to set your chuck force.
Hey, Miguel, if you could just speak up a little bit more, please.
Okay, is that a little better?
Yeah, that's better.
Tools used during the first video presentation is a spanner and a hook spanner. Components that you'll be seeing during the video, starting on the top right, is the cap nut, followed by the collet, the spring, chuck sleeve, and the balance sleeve. Here's a picture from our older generation of the machine. It was a Citizen-Cincom C16. So the process we're performing in this video is going to be no different than the process you would use on our older machines. Now onto our video. Here we got Peter opening up the cover over the chucking mechanism. He's going to be checking for unusual play on the fingers. Always remember to have your chuck open before you try and remove the spindle cap. So remove the spindle cap nut, set it off to the side, followed by removing your collet, and then removing the first sleeve, which would be the chuck sleeve. Now loosen and remove the two screws that are holding the ring cover. Make sure to take note of the orientation of the two holes that are not symmetrical. Now proceed with sliding off the ring cover. Now we're going to begin loosening the set screw that holds the lever pin in place. I recommend not removing the set screw completely, but enough to slide the lever pin out. You don't want to risk the chance of possibly losing a small set screw. So hold on to the chuck finger while sliding the pin out, and then you will be repeating the same process for the other finger. Now we can begin removing the two other sleeves inside the spindle. Here we're using a long plastic rod with the blue tower to help push out the long sleeve. As you can see, we have the guide bushing removed. On the L520, one of our older generation machines, you could either remove the guide bushing to have clearance to remove that long sleeve, or depending on the bar loader that you may have, you can slide those sleeves out the back side of the spindle. Something to keep in mind. The same method we use to push the sleeves out we'll be using to help clean the inside of the spindle. You can use some WD-40 sprayed on a rag, help clean up any of the buildup, break up any buildup inside the spindle, and continue sliding your towel through there. Also, to make sure to clean any buildup on the front side of the spindle, as there can be a step for where the chuck sleeve is seated inside.
Miguel, we have a question here. Should you keep the draw nut set when performing this procedure?
The draw nut, the adjustment nut, we will be loosening that here shortly in a little bit. But yeah, that is something to loosen up when you're also performing this process.
Another question, would the WD-40 cause a problem with the bearings?
We're not specifically spraying it onto the bearings. I mean, as you saw, we're spraying down the rag. We did spray some a little bit in the spindle, but it's not going to be traveling direct. It's not going directly into the bearings for, say, the spindle.
Thank you.
And here we're also going to spray some WD-40 over the finger holder and the ring cover, because you do get a lot of buildup over time. Make sure you clean out, some of the edges around the finger holder where buildup can be built up. Apply a little bit of motivation to get the finger holder to move forward. There's times that you'll get a lot of buildup where the keyways are for the spindle, for the finger holder. And then we're also going to clean around the relief point in front of the adjustment nut. So we also want to check, that the adjustment nut can be threaded forward and back easily. We don't want any buildup in between the threads. It can, any of that can damage those threads over time. When you get a lot of severe buildup under the finger holder, it's going to take some time to work it back and forth to try to get all the chips and debris to kind of clear up where the keys are. So you'll be working it back and forward. Inspecting the bobbin bearing, it's really important. Worn out fingers can tend to leave a groove around the area where the fingers right up on, and you also want to check the seals around that bearing for any possible damage. Here we're checking the lubrication system to make sure that we're getting some flow onto the bobbin bearing and chuck fingers to help prevent any premature failure. Inspecting and cleaning the fingers. So these are some of the areas that we clean, where all the buildup comes up. Make sure, that the holes are clean on the fingers. We're also going to be checking the radius on the front side of the chuck fingers to see if there's a flat. They usually develop a flat in the middle and work their way out to the edges. Later on, I will be showing a slide showing the difference between a new and worn out fingers. Some of our older generation machines have these lever pins but don't have this slot cut into them. So these are the areas that we're checking for any wear. So it's a good idea to help mark where that groove is set. That way, when you start to put the pin back into the finger holder, you know where to line up and match it with the set screw. So here we're placing the finger back into position, putting the pin in with our marking facing up towards the set screw. Make sure the pin is orientated the right way. Now we start to tighten the set screw, loosen it, and then completely tighten it afterwards. This will help ensure that the set screw is sitting flat onto that groove of the pin. And then we'll repeat this on the other side. So now we're starting to slide the ring cover back onto the finger holder, back into its position. Like I said earlier, make sure that those holes are lined back up into the correct position. It's very important that the screws are identical. There might be a time when you find yourself at a customer and the screws are mismatched. Make sure to correct the screws to ensure that the spindle stays balanced. Install the screws and evenly tighten them. Now we're starting to clean the balance sleeve and the long sleeve. We're going to use the long rod that we used earlier to make sure that the balance sleeve doesn't flip around when we're trying to put it back into the spindle. Next, grab your chuck sleeve. Same thing like we did with the balance sleeve and long sleeve. Make sure it's cleaned. Make sure that there's no chips where the spring sits. Line it up, slide it in and line it up with the key. Don't try to just slam it into the spindle, as you can cause damage to the key that's on the spindle. Now, put your collet back in, cap nut, and tighten everything down. And that's it for this portion of our presentation. Do we have any questions, Joe?
No questions at this time. I'll give it another minute if anybody has any questions.
Okay. So it's really important to take a look at your balance sleeve, your sleeve, and your chuck sleeve. As you can see, there is a concave edge right around on the front side of the sleeves that are going to be mating with the back side of the sleeve. Same goes for the front side of the long sleeve, mating back to the chuck sleeve. It's real important that these don't go in the wrong way.
There doesn't seem to be any further questions.
Okay.
So thank you, Miguel, and thank you, Peter, for the demonstration. Thank you, everybody, for attending.
We still got more.
Oh, there's more. Sorry.
We're not finished. So broken lever pins, these can break. Don't try and temporarily fix it using a drill shank or any type of soft metal pin. These pins are made of carbide. You want them to just break under pressure. If you have something that's soft, what can end up happening, it's going to bend and you'll never get it out. Or you can, but it won't be fun. Here's a comparison shot between some worn out chuck fingers and new chuck fingers. As you can see, here's the flat that gets developed. It's going to start in the middle and just work its way out to the edges. The portion up here that is hit, that goes up against the balance sleeve, will start to wear out over time as well, as there's a small radius on here. So now we're going to start talking about setting the chuck force. On the left are the tools from our Citizen-Cincom N532 for setting the chuck force adjustment. Your tools might look a little different, but are going to be used in the same concept. Older generation machines that have a servo-driven chuck were able to use an auto adjustment feature to set your chuck force. So here we have the two Tommy bars and the chuck open and close tool. On the right, we have the chuck force graph, which you can also find in the instruction manual under mounting and adjustment, and also the machine preparation under chuck force. There's two different graphs. One is going to be related to your main spindle and one for your back spindle. The bottom side of the graph is going to be showing your degrees that you will be using with your adjustment nut. And on the left hand side is the force that's being applied when the spindle is being chucked. Now on to our second video. So make sure the chuck fingers are moving the sleeves forward freely. Here we're just raising the fingers up. Our cap and collet are out of the spindle. We're going to be inserting our collet, tightening down the cap nut. Here we're using a 625 thou collet with the 625 thou pin to set our force. We're going to be removing the pin from the chuck air cylinder. Make sure that your chuck is open when you do this. And then we'll be setting our chuck open and close tool. Here's a shot of how it's going to look with the tools in place. Our pin is still not chucked. The chuck's in the open position. Using your tool, close the chuck. You can see our pin is still moving freely. Using the Tommy bars, start to adjust your adjustment nut. As you can see, we're still spinning the adjustment nut, tightening it up against the finger holder. Our pin still, the collet still hasn't closed up on the pin. All right, now we're starting to get somewhere. Pins isn't moving. This is going to be our starting point for setting the chuck force. Now, right when you have the nut tightened enough to where the pin just starts to be chucked up on. As you can see on the finger holder, there's these markings. Those markings are 15-degree increments. Here we have Peter pointing to them, and they're all the way around the finger holder. So opening the chuck is ideal when finally setting your final chuck force. 4 to 5 marks from where your starting point should put you in the middle ground for chuck force. Too much pressure can lead to unnecessary wear on the fingers or even broken lever pins. Open and close the collet, check the pin or material. It's very similar in feel when manually chucking on a manual lathe. Some like to listen to the sound that the collet makes when it opens and closes on material. Doing so is incorrect and can potentially end with chucking issues. Here we're inserting the pin back into the air cylinder. Again, make sure your chuck is open. And finally, we'll be locking down the screw on the adjustment nut. Now you're ready to go.